So yeah, I will do a presentation about the glTF sample pure, but before I talk about the implementation details of the past year, I will first give you some, introduce myself and show you what I'm doing. So yeah, I'm a senior GPU software engineer for UXPD since 2019. I have a master degree in games engineering, so I have a bit of a games background. I worked on the title, which was the first visual glTF editor. We released this in 2021, I guess. And since 2020, I'm working on glTF sample viewer and also maintaining it. I'm also the project lead for the dynamic performance test field. For example, here on this is the glTF clean asset in this RTX. We are rendered via an Navi device. And yeah, and here in the bottom you can be a gestalter actually. I'm also currently researching ghost splitting, and I wanted to do like a joke with breaking the ice in scuba diving, but I'm German, so I just go. So what is glTF sample pure? glTF sample pure is the official Khronos implementation of the glTF format in WebGL. The project started in 2017, and at that time it still used WebGL 1. Then in 2019, it was switched to WebGL 2. Yeah, it's actively developed and maintained by UXPD, where I'm working, and it supports all verified PHR extensions. We are also implementing experimental support, for example, for diffuse transformation currently, and but for WebGL and neural mesh instancing. We also have glTF validator integration. So you can see it on the right side. So you can also directly have like visual feedback and feedback about the specs. And yeah, there's IBL for different debug channels for the different material properties, for example. And it's also integrated in the render fidelity tool, so you can compare it towards Babylon, for example, or feature-ins. It's also available as an NPM package and therefore also used in other Khronos projects, such as the glTF compressor or the glTF external format demo, which I'm gonna talk about later, and the 3D commerce certification as well, for example. So yeah, let's jump into implementation details, what we did last year. So yeah, we implemented animation pointer. So previously, without the extension, you could only animate node transform or morph targets, which were like void vertex kernel, maybe, but most engines didn't use support that. And now with the animation pointer, you can basically animate anything, more or less. So you can just find a JSON pointer to a property in glTF, and yeah, create a sampler and change it basically. So yeah, as you can see here, and like some material properties which are animated in that case, but you can also animate cameras or lights or texture transform, and also all future extensions. This will also be a big part for effectivity, for example, in the future. So for implementation, there was kind of a problem. So every property now could be animated. So how do we change that without touching all the whole code base? So yeah, we basically used JavaScript getter and setters. So then we just have a parent class which implemented the getter and setter, and we have like a November class for the animation. And it's really nice because in that case, all the code could stay like it is basically, and other developers who can also contribute to the open source project, they don't need to know if something is animated or not. They can just use dot notation normally, and yeah, and don't need to know that there are an animation at all. And a different point here is that for future extensions, we also added error handling. So if someone forgets about animation pointer, you cannot run the program. So basically. Another thing we did, which was quite a major change actually, was last year was an issue raised in the glTF repository, and the non-normative section of the PBR shader implementation was actually incorrect mathematically, and so that we need to change the shader code. And as you can see here, like in the old renderer, for example, for materials which were mixed, so not totally dielectric or metallic, the furnace test didn't work. So the energy conservation, wasn't as expected. And now with the new shader code, you cannot see the object anymore. So to go to a bit detail here, so this is the PBR workflow for glTF. And before, with the simplified version, we assumed that metal had like a diffuse part of 0. And with that simplification was assumed that pre-mixed the personal term and also we just added the diffuse and the spectral parts together. So you can see this here. And if you have a close look at the functions on the left side, you can see that metallic is actually used twice. But here, metallic is only used at the end in the mix. So that's where one of the issues comes from. And so now in the new shader, we cannot do the simplification anymore. We just do the workflow by how it is defined in the diagram, basically. There was also an issue in the IBL shader code. So this is basically the shader code if it would be a full metal material. And as you can see, in the old IBL shader code, there was a diffuse part, which is not incorrect. So that here the input shouldn't be any contribution. And here I can show some comparison. So this was the old shader, and this is the new one. So on the left-hand side, you can see a grid with metallic roughness values, and on the right side, you can see iridescent. And for iridescence, it was like a really big difference, as you can see, because it is based on the base color. And in the old approach, the base color was pre-mixed. That means, there was just the wrong base color used. Obviously, like, it should linearly place between this and that. Okay, and then the next topic. So we did some exploration for the glTF external reference format. This is still an experimental state. We're actually looking for feedback on this format, and if it makes sense to implement it and what is needed there. So we did a project to figure out what are some use cases for glTF external reference format. The format itself is only JSON based, and the reference is glTF, but can also reference other file formats. For example, it could reference HDR files in the future, or other 3D data, or meta information, or whatever. And it allows you also to switch the underlying data without changing the file itself. Like if you have a new URL inside the file, you can just put a different file, obviously, and then it will automatically change without you needing to change the file itself. So what we did here was, for example, one use case is asset-based lighting. So you can either light only the asset like one asset, or you can like multiple assets. And the same goes for IBLs. So you can have different IBLs for different settings, IBLs for indoor, for outdoor. Then there's also LOD. So yeah, but in this video, the exaggerated. So obviously it should be very smooth, but then you won't see the effect. So yeah, with this format, you can specify multiple glTF files and load in on demand, for example, or load them based on distance, screen coverage, pixel quality. Yeah, so we have some different metrics, and the renderer itself can decide what to do with it, basically. Then we also looked into billboards, but for billboards, we decided that it's actually better to do the glTF extension on a node, so that the node always looks towards the camera. We can have either cluing for the billboards, or can also have always in the front scale the camera. Can also do axis aligned billboards like these trees. I mean, that's all stuff you probably know already, but it's probably not in the glTF. But and then there was a scene arrangement name. So this is like picking and selecting, and so you select the different assets in the glTF X file, and you can move them on top of each other, reparent it automatically, and also use the surface normal to arrange it correctly on the surface. Yeah, that was the stuff we did last year, basically, and now there will be more things in the future. For example, we will implement volumetric scattering using the very normal diffusion. That is the same algorithm which is used in Unity and Unreal as well. And then there will be interactivity in the future, physics, audio, for example. And yeah, and all of this is open source. So feel free to contribute and look at the code. Same goes for the external document format. If you have some ideas there, or just open up the request, for example, create an issue. And if you are actually implementing a glTF renderer, then have a look at your PBR code. We are currently trying to get Babylon and VJS on the same page that they need to update the data group because it's currently not correct. And and in general, just ask a question about mission and adoption of glTF. So today, later you can come to me, and if you have any questions regarding any feature, I basically implemented our glTF features at some point. And just be open and talk about what you would like to see in glTF. Yeah, via some references, and you can also contact me via my email address, or if you want to see other stuff we do, you can go on to the WebGPU IO company website.